one last thing on the topic of coupling, once we move out from an application sense to a system environment, the number one thing to be careful of is hidden coupling via some kind of shared resource, where instead of A calling B directly, A is putting stuff in the database and B is reading the exact same stuff from the database. Effectively, you have a form of A calling B, but you just don't see it. All right? So you got to be careful anytime that you're introducing some kind of shared resource into the mix. Now again, doesn't matter if the database is wrapped up by some sort of REST service. If you have something that's doing a create against that REST service and something that's doing a read and update on that same REST service, effectively you've got a shared resource. It doesn't have to be an actual database that you're talking to. So that's really the number one rule of thumb when doing design, is make the coupling explicit. Right? Dig it up, make it visible, and then you can start to manage it. The concern being, oh, I'll just put a bunch of data in here and send over an ID. Be careful with that, because that means that there's some kind of implicit coupling between the two of them. Some amount of this is unavoidable. All right? When you have two pieces of code that are going to be operating largely on the same data, they're going to be coupled to each other. But one of the ways to mitigate that, try to keep the data that they're coupled on as narrow as possible. Narrow meaning you don't want there to be like 50 columns of data in that table that they're all talking to. All right? So the more narrow it is, usually the better. Yeah.
But just to be clear, if A and B are dealing with two different representations of the same shared resource in the database, that's still coupling.
That's correct. So if A and B are dealing with different representations, and again, in REST they make a big deal out of representations. But if fundamentally, semantically, they're dealing with the same data, the same business concepts, where you're using an address and I'm using an address and say, oh, but I call it a shipping address and you call it a delivery address, it's still the same address. And and we need to agree on how an address looks. And there's apparently, for those of you, I think it's in the Netherlands, I remember hearing that that you have additional ways of numbering things in addresses. So apparently the Netherlands addressing data model is slightly different from other countries, where you have things like the street and the house, and then inside the house you have like other numbers, because
or that you live with your boat besides the street.
Oh, okay, right. The boat address element is. So that element of saying, oh, it's just an address. Well, there can be complexity around addresses. Every domain, once you get into the details of it, you realize just how messy it is. So yes, any type of element we're saying, oh, it's just a different representation of the same concept, so we're decoupled. Our concern is that when the business rules change, they change in terms of the business concept itself, and that tends to ripple out and affect all representations. So that whole element of, no, I'm just using a transformation, or this is a read-only copy of the thing, it's still a form of coupling. All right, Chris?
Is there a good static analysis tool that will give you reliable figures for afferent and afferent?
Right. So what static analysis tools are out there? There is a bunch of them. Most of them are not able to solve this sort of problem well, especially over remote calls, where you're saying, well, I'm taking a dependency on some REST resource, then it doesn't pop up in the form of the code. But I'd say that get familiar with a static analysis tool that makes sense for your environment. Depends very much on the programming language that you're using. So obviously there's going to be a difference of static analysis on PHP as opposed to .NET, right, or Java. So statically typed languages are easier for static analysis tools to reverse engineer the, oh yeah, I can see that there's a certain number of outgoing dependencies. JavaScript, more difficult. PHP, yet more difficult. But the first step, like I was saying before with the GitHub and using the issues, take that first step. Introduce a tool, even if it's an incomplete, imperfect tool. Start having conversations with the team about what these numbers mean and that why we want to conform to certain numerical patterns, and encourage people to try to follow them. So I'd say the best known one in the .NET space is ndepend. Java has quite a bit more, but I believe that ndepend or xdepend, whatever they call it now, also does Java code as well. There's some JavaScript ones. So really, let me Google that for you, JavaScript static analysis. I'll say, well, there really isn't static analysis per se for JavaScript, but if you're already thinking about, I want to do static analysis on top of my JavaScript code, you should be really looking at TypeScript to begin with. And once you're on TypeScript, then the regular static analysis will apply. All right?
Yeah, so we use Sonar at the moment, but I'm not sure if that gives us these figures. And if it does, I'm not sure it gives us to them with this kind of naming convention. So I was just wondering, does ndepend present this in a way that we understand it from this course?
Yes,
or is
it does.
It does.
It does.
Right. All right. I know you have more questions. We do have to make some progress. Let's talk at the system level. All right. So first of all, obviously we want to keep the incoming and outgoing coupling low. All right. The important thing, and I want to drive this point home, not mechanically low. You don't want to have a place where developers are saying, oh, that's a 5? All right, what I'll do, I'll get rid of that. I'll just have a do-it method, right? And I'll pass in a parameter via the do-it method, and then over here I'll have a switch case inside, all right? So you don't want to encourage developers to work around the system in order to keep their numbers low, all right? So you don't want to be tying these metrics to any type of performance assessment of the developers. Just explain what you're doing, why you're doing it. So let's say we want to keep these numbers low from an actual design perspective, not by hiding the coupling better. All right? That's what we said over here. Don't want to hide the coupling, but we want the numbers to be as low as we can organically make them. As we mentioned, zero coupling isn't really possible in the sense like D having 0 and 0, but when there is a 0, it should mean something. In other words, if this is UI code, it shouldn't be called by anything else. Or if this is a DTO, it shouldn't be taking a reference on anything else. So if there's a 0 that's an inherent part of that pattern, you want to enforce that as a part of your rules. All right? In addition to those logical elements of coupling that we've been spending so far this afternoon talking about, there are 3 additional aspects that we're going to go through really quickly. Starting with platform coupling. So platform coupling is that fallacy number 8, the network is homogeneous interoperability that we talked about before. When dealing with a given logical link between 2 pieces of code, usually what we're looking at the system level is saying these things are now deployed potentially separately from each other. What kind of protocols could we use in order to talk between them? Now, if we're using binary serialization, remoting in .NET, remote method invocation, RMI in Java, then we're going to have a higher degree of coupling to the platform. Whereas if we're using a more HTTP-centric XML JSON, we're going to have a lower degree of coupling to the runtime platform. All right? So for a given link, we can say that there is high platform coupling, low platform coupling, and you could say there's maybe a middle ground somewhere in there. So ultimately it's saying we've got these 2 pieces of code that logically need to talk to each other. Are they bound to a specific platform, or can they, in essence, evolve on different platforms? And this is where the good old days of web services and service orientation came about, saying share contract and schema, web services, WSDL, XSD, and that kind of garbage, not class or type. So all that binary serialization being out. That's platform coupling. Temporal coupling deals with the coupling on the dimension of time. So if we have 2, and I'm going to use the term service very loosely here. We have 2 pieces of code where one is calling the other over the network. And the calling service, A over here, is not able to do anything meaningful until it gets a response from B, we'd say that there is a high degree of temporal coupling between them, where the runtime execution of B has a direct impact on A. If, on the other hand, A can do an asynchronous invocation, where it fires and forgets something off of a queue, and it can continue doing meaningful work in the meantime, then we'd say that that's a low degree of temporal coupling between them. All right? And to be clear, temporal coupling and platform coupling are independent from each other. In other words, we can say we have two pieces of code that are temporally decoupled. We're using a queuing system to talk between each other, but we're using binary serialization for the messaging part. So we are now having a high degree of platform coupling. And it can be vice versa as well. All right, so each of these aspects is independent of the other. The third aspect is spatial coupling, and this gets to the fallacy of topology that we talked about before. How bound am I to a specific machine in order for my execution to operate? Obviously, if I have a hard-coded address that I'm talking to, if that machine goes down, I can't fail over to something else. That would be a high degree of spatial coupling. If things are able to fail over, hopefully automatically via, there's a load balancer in the middle, there's no configuration that needs to be updated, or that I'm using DNS and that the DNS system automatically updates itself as machines come and go, then that would be a lower degree of spatial coupling. We're not going to spend too much time talking about the spatial coupling. More of that is physical and deployment concerns. At the end, we're going to loop back. There is one design element to dealing with spatial coupling that we've talked briefly about before, that we're going to touch on when we get into solutions.